Welcome to Study Loop.
Hi there. So for this problem, we are told that Newton's law of cooling tells us that the rate of change of the temperature of an object is proportional to the temperature difference between the object and its surroundings. This can be modeled by the differential equation that is the following. The derivative of the temperature with respect to time is equal to a constant of proportionality k that we can determine by using the initial conditions, and this times the temperature minus a, which is the temperature of the surroundings. Now, for these problems, we are given some information. We are given that we need to suppose that a cup of coffee begins at a temperature. So we are given the temperature at the time equals to 0, and that temperature is 188. Now we are also given that the ambient temperature is 69, and the temperature of the cup of coffee after 17 minutes it's equal to 178 degrees. And the question in this problem is to find the time when the temperature of the cup at this time is equal to 164. So with that information, we begin by separating this equation in the variables. So we pass this term that depends on the temperature to the left side, and the temperature and the time, the differential in time, to the right side. So with that said, we are going to obtain that the differential in temperature is divided by the temperature minus a, and this is equal to the constant of proportionality k times the differential in time. So we just simply integrate both sides of this equation. For the left side, we know that that is the Neperian logarithm of the temperature minus a, and this is equal to the integral. We know that k is a constant that we can take out of the integral, so we obtain k times the time t, and of course we will consider a constant from that comes from the integration, a constant of integration. So now to get rid of the Neperian logarithm, we apply the exponential function to both sides of this equation. So we obtain the temperature minus a is equal to the exponential of k times the time t times the exponential of c. We said that we're gonna set that this is equal to b, so we obtain b times the exponential of k times the time t. So if we solve for the temperature of this, we will have that this is b times the exponential of k times the time t, and this plus a. Now, to find the value of b, we use the first condition that the temperature at 0 is 188. So if we substitute in here in the time 0, we will have the exponential of 0 that we know is 1. So we will have that the sum of these two values should be equal to that. So if we solve for b, we will have that that is 188 minus a. But a is the temperature of the surroundings, which is given, and that is 69. So from this, we obtain that the value of b is 119. So with that, and we now have that the temperature is equal to b, which is 119 times the exponential of k times the time t, and this plus the temperature of the surroundings, which is 69. So we have that for now. What we need to determine now is the constant k. And then to use that, we use the other condition that at 17, we have a temperature for the cup of coffee of 178. So in this case, we will have that this is 119 times the exponential of k. And here we substitute the time, which is 17 plus 69. Now, if we solve for k, that's quite easy. We can pass this to the other side and divide by this, and then apply the Neperian logarithm. So we will find that k is equal to the Neperian logarithm of 178 minus 69 divided by 119, and this divided by 17. So from this we obtain that the constant k, it has a value of minus 5.16 times 10 to the minus 3. And now, finally, we will have that our equation for the temperature with respect to time is 119 times the exponential of minus 5.16 times 10 to the minus 3 times the time. And this is, oh, sorry, I forgot the temperature of the surroundings, which is 69. Now we need to find the time when this temperature is the value that we are searching for, which is 164. So what we are going to do is to simply pass this to the other side, divide by this value, and apply the Neperian logarithm of this, and divide by the constant k. So that from there, we're going to obtain the time, because that is the Neperian logarithm of 164 minus 69 divided by 119, and this divided by the constant k, which is minus 5.16 times 10 to the minus 3. Now, if we use our calculator, we obtain a time of 43.65 minutes. So that's the solution for this problem.